Ready to get into the stream, ready to get programming, ready to get fixing whatever problem we had yesterday. Good morning. Welcome back. We are on chapter 11.3 of Crafting Interpreters. We were working our way through the resolver and trying to get that working, and I have an issue somewhere along the way that I need to fix. I need to resolve. Cargo check. In that we can't borrow as mutable the thing that we're borrowing is mutable, which I gave it a little bit of thought, and the only thing I can think of, so we have a ref cell which gives us a vector, a mutable vector of hash maps, and that's what we're trying to play with down here. We're allowed to push and pop. It's not complaining about the push and the pop, but it is complaining about this one. This insert and insert here for declare and define. So I'm going to hack around the problem for now. I'm guessing the problem is that although the vector is mutable, the hash map it's vectored to is not. So I'm going to just try this and see what happens. Wrap the hash map in a ref cell. Which means that when we create it, oh yeah, we can still create it with vecnew, right? But when we push it, we have to push a ref cell new. Right, and then when we unwrap the last one, we have to do another borrow mut. Actually, this one doesn't have to be mut anymore because we're just looking it up. And the same with define. So let's see if this works around the problem. It does. Okay, so that was the issue, that although the vector was mutable because it was in a ref cell, the thing it was pointing to was not mutable because it was not in a ref cell. I guess the other option would be to just make all of these take mutable references to self, and I don't know how much that would break. Maybe we should try that, because we are having a problem with this interpreter where I also have to have a double ref cell. One ref cell to modify the environment and the other ref cell to actually replace the environment from one to the other. But if instead of using ref cells everywhere, if I just have mutable references to self, that might do the trick. And I forget why I went down this path instead of the other path. So maybe it's time to just play around with that this morning and see if that works. Let's check this or commit these changes. Git check. Sorry, cargo check. I just want to see, I think it's just all these experts need to be, and statements, yeah, need to be underscored. Okay, so we can do that just to clean that up for now, and then we can, so we just get underscore. This one's okay. And this is var statement we did. And then we have expert. Let's go to the top. Oh, we had it right here. There we go. Yeah. No, no, there's three. Ooh, did I do one I shouldn't have done? Yep. There. So what's the last one? We don't need the interpreter yet. And we don't have a new. Okay, so we can ignore those two. Git status, git add source, git commit, starting work on the resolver. So what I want to do then is, I want to change this so that it generates mutable references to self in the visit functions, right? And this is going to change everything, right? So if I try to build this, it's probably going to fail. Yeah, because all of these need to be mut self now. Actually, for the resolver, we can just comment that out. Let's comment out the resolver for now, and just work on the interpreter. And see if we can get it to the point where we don't need the ref cells anymore. We might still need the RCs, but not the ref cells. And what does this blow up? Yeah, so now we have a problem. Help consider this to be a mutable dynamic expert visitor. Okay, we can try that. That's down here. But this also has to be mutable, right? Still have 17 errors. Oh, and then this guy here has to be mutable. Okay, so append accept. So this is mutt. And mutt. Only have 2 errors left, and it's here. Yeah, but now the Barda checker is going to kick in. Once this compiles. Yeah, okay. And we have 6 issues. So mutable borrow occurs here, a mutable borrow later used by the call, and a mutable borrow occurs here. So we can't do things like this anymore. How do we fix this? I think we have to have a separate variable. We can just say let result is equal to self-evaluate statement condition. And then we can just say if, oops. Oh, we have to say mutt because we have to use it again. And then we just say result here, and then we have to copy, paste, like that. Okay, let's see if that solves the first one. Nope. Okay, so it fixed that one. Okay, so we just have to have this kind of awkward construct. So that, right? And now this needs to be mutable. And we have 4 warnings, sorry, 4 errors and 2 warnings. And now we got down to 21. So expected mutable reference and found just a regular reference. And that's this value here. Do I have to say mutt value? Okay. So we just have to put mutt everywhere? Is that true? All right. I mean, we're walking our way down. Although I don't understand how this can be mutable if we don't pass an immutable statement. Are we going to run into the next problem here? So after we do all this, it's going to complain that something else is going wrong, right? Oops. All right, and now what blows up? One error. Oh, I missed this one. Yeah, so now we have 29 of these guys saying these data has moved. Can I do that? Expected enum expert found mute. Yeah, but I'm trying to make it. This is the only error left? I find that hard to believe. Because we do this kind of thing all over the place. Yeah, I can't remove that because then it's going to blow up. Yeah, we have 20 places where we can't do this. Right, so if I put mutt here, which is going to fail because we don't have it like that. Right, that it doesn't have that type. Let's try changing that type then. Oops, generate. It's right here. Right, so all these need to be mute. And then remember, we're going to have to go back and fix the resolver. Expected mutable reference, found reference. Right, so this is where we have to put mutt here, right? And then we have this. Consider barring mutably here. And we tried that before. And then we can't do that because we're moving the data. And I don't want to move the data, I just want a reference to it. Ooh. And if I do this, it's going to say you can't do that. I don't think there's a way around that. This is probably why I didn't have it mutable from the start. I don't actually want to mutate the return statement though. I don't want this to be mutable because it's just a statement. I don't mind the self being mutable because we want to be able to mutate these guys. Self-evaluate. Let's see. Let's take a look at that. Oh, that's why I have mute expert, and then accept needs a mutable reference. Is the expert? It does. Yeah. So I don't think we can do it this way. So let's undo all of that work and start again. So cargo check. Yeah. So the reason I was going down that path was to see if I could eliminate all these ref cells, and at least not with this pattern. I can't. I'd have to probably rewrite it in a very a much more rusty way. But we're following the Java style here, so oh well. I tried. So let's pull the resolver back in. And we were here. We just got this to type check by doing this double borrow. And now we're doing visit. We're about to start visit variable expr. Okay, so it's section 11.3.3. So we're finally doing the exprs. Variable declarations and function declarations, which we'll get to, right to the scope maps. Those maps are read when we resolve variable expressions. First, we check to see if the variable is being accessed inside its own initializer. This is where the values in the scope map come into play. If the variable exists in the current scope but the value is false, it means we've declared it but not yet defined it, and we report that as an error. Okay, so let's write this code here. It's being reported as an error, but we're not. Are we stopping? Are we throwing? I guess we're throwing that. And just stopping at that point. So we can just say if self scopes. How do I check to see if it's empty? Borrow. It's empty. Sorry, if not. And scopes dot self scopes last, borrow last, unwrap, borrow. This one's annoying. Get. Let's see. We have expr name, and I call it as string instead of like seeing is false. Oh, then we have to unwrap it also. So basically you just put another not in front of here. Right? And then we'll just throw the error. Locks error, error. Locks results. Is this a runtime error? I don't know. Runtime error. Expert name. Can't read local variable in its own initializer. Else, we're going to do this resolve local and self resolve local. Expr name, and return OK. Oh, and then we have to write resolve local. Okay. After that check, we actually resolve the variable itself using this helper. Oh, so we're finally using the interpreter now. Okay. So let's write that. Fn resolve local, which takes an expr, gives a self first, and an expr, and then a name of token. So what is this doing? For int I is scope size -1, I is greater than 0. So it's going in reverse order, and it's looking in that level, at that level of the scope, to see if it contains the lexeme. And if it does, then we return scope size -1 -I. So that's basically how far back we have to go. This looks for good reason a lot like the code in environment for evaluating a variable. We'll start at the innermost scope and work outwards, looking in each map for matching name. If we find the variable, we resolve it, passing in the number of scopes between the current innermost scope and the scope where the variable was found. So if the variable was found in the current scope, we pass in 0. Immediately in the closing scope, pass in 1. You get the idea. If we walk through all of the block scopes and never find the variable, we leave it unresolved and assume it's global. We'll get to the implementation of that resolve method a little later. For now, let's keep on cracking through the other syntax nodes. Right, so we're going to call interpreter resolve. But basically we're just walking our way backwards through, we can say self, scopes, borrow, iter, rev. The only thing is coming up with this number here. Scope and map enumerate. Can we do it that way? Right, and that way the first one will be 0 and the next one will be 1 and so on, and we'll do it in reverse order. And we can say if scope dot, map dot borrow dot get contains key, right? Name dot as string, then we call the interpreter itself interpreter, and we pass in the expr and the scope, and then we return. Oh, self-interpreter resolve. Okay, so we don't have the resolve function yet, but we can stub it out. Oh, I forgot the in. Oh, I forgot the space. There. Right. Well, the second one's easy to fix. And so is this one. Let's fix this one. And we don't have resolve, yeah. But I'm stuck on this one here. Expected reference expr, found reference variable. Oh, right. We're passing in here. Uh-oh. We got the expr variable, which I didn't do the same way that they did it. Our expr variable is not an expr. If we take a look at this, our variable expr is its own struct that we destructure here when we call the accept functions. And yeah, not here. They're already destructured by the time we get here. What does resolve local, the interpreter resolve need? Can we get away without that? Let's take a look at resolve local. I'm just going to scan forward. What does resolve? It maps exprs to integers. Oh, so it's saving the scope. Hello, Aura. Good morning. It's morning for me anyway. So we're saving in here, in the interpreter, we're saving for every expr. Every node we visit that's an expr that has a variable reference is going to have a scope for itself, which makes sense. That's what we've been doing. Is this book written in Java? The first half is. So the first half, well, I mean, technically, if you want to get pedantic about it, it's written in English, but it's all Java code in the first half. Let's take a quick look here. Yeah, so if you look here, this whole tree walk interpreter, so we're on resolving and binding. And so this is all written in Java, right? This is all designed in Java for the tree walk interpreter. But if we get to the bytecode virtual machine, when we get to the bytecode virtual machine, this is all written in C code. So I'm also going to try to write this in Rust. Or it says, I'm only a student, but I quite like Java. Yeah, I like Java too. I've used Java professionally and non, so it's a decent language. Mumin Jamala says, I can see why you want to port it to Rust. Well, yeah, so I want to port it to Rust because I want to learn Rust. And it looks like now that I've gotten to this point here where we just met a giant stone wall. Or it says it's very easy to understand because it's so verbose. Okay, I'll grant you its verbosity. Yeah, and it's probably a very good beginner language. I know the high schools here use it in their advanced programming classes as a teaching language. So it was pretty good. I don't think it was designed to be a teaching language, but it works that way. So. So where do we go from here? Because now we hit this brick wall of we're trying to resolve exprs into scopes, but we don't have a generic type anymore because we've destructured it into the individual type. So, oops. All right, so let's set the resolver aside. All right, let me just save that real quick. And so we have these two errors where resolve local is expecting an expr and not getting it, and then interpreter resolve doesn't exist. Do we need, so I'm looking at our expr code. Do all these visits need to include the actual expr type, right? Because we call visit unary expr, and we have our unary expr. We don't have, at this point, we don't have the expr itself. Mumi Jamala says, I'm of the opposite opinion. It's hard to understand because there's so much extra stuff you need to know about. I think the beginnings of Java, right? So learning about variables and methods and loops and things like that are going to be applicable to just about any language you're going to meet in a work environment, right? So if you learn those basics, you get all of that information, and it is slightly more approachable in that you don't have these weird. Well, I shouldn't say weird. You don't have these unusual syntax choices that, for example, C++ made, right, or Rust made, with question mark operators and turbofishes and stuff like that. So you can get everything without having to get lost in syntax, I guess. I'm going to go with that. Let's go with that. Mummy says, I mean, just to write hello world, you need to know about classes and imports and scopes. I see what you're saying. Yeah. I mean, what's hello world in Java? It's just class hello, public, static void main, arg string. I forget the syntax already. String arg is probably like that, and then system out dot println hello world. Right, so this is what you need to do to write a hello world in Java. So you need to create a class, you need to create main, and you have to understand, oh yes, there's a static keyword in there. And then you're doing this dot construct in order to just get this out. So I see what you're saying. Whereas Python hello world is just print hello world. Oh, right, it's functions now. So that's a difference. You can make an argument, I suppose, that might be simpler than this. Oh, you scrolled down, Aura? Yeah. Okay. All right, let's get rid of that, and let's figure out what I'm doing wrong here. What do I need to do then is I have to pass in the original, right? The original self here. So I'd have to say for each one of these, put a self in there. And then modify the accept statement where the accepts. Every accept then would have to have Why are we going through this extra step of accept? We should be able to just call it directly here, right? We should be able to just say, right? We should be able to say visit assign expr. Expr visitor, visit assign expr, and then pass in pass in what? Self and v? Because we have destructured it, might as well pass it in. And that would, I think that would get rid of all of these things down here. Right, because all this is doing is that one line. So we don't need to do all of that. Okay, let's try cleaning that up. Okay, so I can't do it there, but let's go into our resolver. Oh, let's comment out the resolver, right? Like we did before. And that way it'll compile, and then in our generate AST, let's try doing this modification here and cleaning this up. So in our accept, let's take a look again. Source expr. Yeah, so we have pub fun accept, but this is the wrong one. Yeah, it's this one here. Right, we have expr visitor. Oh no, that's the wrong one. Oh yeah, here it is. Expr visitor, right. Match self, and then so what we do is it says expr assign v. So we want to change this to expr visitor. Then it would be visit assign expr. Oops. Like that, and then it'll take self and v, like that maybe. And now we have to change all these things. So this is 0. This is 1. Oh, we don't have to put the numbers in because if we just do t base class name to lowercase comma. And if we call that directly, we don't need all these guys here. When we say impl there. Yeah, this one. So we can comment, let's comment this out. And now if I run this, everything's going to break in interpreter because now we suddenly have a different function signature. Expert visitor right there. Oh, I spelt it wrong. Oh, yeah, it can't be expert visitor. It has to be the name visitor. Okay. Okay, now we do need the numbers. That's the base name. That's the base class name. That's the base name to lowercase. That's the base class name to lowercase, and that's the base name to lowercase. All right. Expected 1 argument, supplied 2 arguments. Okay, so now we need to modify expr visitor, which is right here, to take both. Edit, another mod here. So here's where we define it. It's going to be an expr of that type, but it's also, oh, it shouldn't be called expr, right? 0, 1, 1, 2. But we're also going to include the expr itself, which is going to be 3. Oh, we're going to have to call it something else. We're going to have to give it a wrapper, which is going to be the base name, ampersand 3. So base name. Okay, and now all these are broken. Let's take a look at our expert and make sure that looks right. Oh, I don't have it there. That's right. Yeah, so it has a wrapper of an expr, and we're passing in that here as self. And then we have the destructured version of it here. So if we look here now, we're going to have to put in wrapper everywhere, which is going to be unused. Which is annoying now, but we'll need it for our resolver. Oh, now this is an expr. Okay. All right, so we're now back to being able to compile. Now we flip back to our resolver. We have to do the same change for the resolver. Oh, Shrishak says even Rust Hello World is so simple. Yeah, it's just FN main. Println Hello World. And you don't, I mean, there's the bang in there for the macro, but you don't even have to describe macros. You could just say, okay, you put a bang there to print. And nobody cares. Okay, yeah. Let's go back to main, and we'll re-comment that in, and then everything, of course, breaks. So now we have to add our statement. Expr, oops, we want to say this is expr, and then for the ones where we need it, we'll just change the word, we'll change it to wrapper. Right, so this is the one where we need it, right? So this is wrapper, and this becomes wrapper. And then we still have an error. Oh, I never wrote this. Okay. So let's write that real quick, because this looks, it's simple. It's 4 lines of code. And that way we can get this to compile. So in our interpreter, we now need something called a locals, which is going to be a ref cell because we need interior mutability. And it's just a hash map of expr to integer. Is this even going to work? Okay, use standard collections hash map, and then fn new. I have to add do you think this would create no, it wouldn't. It might. Let's try. Oh, can't use a comma. Oh, integer. What am I doing? Use size. Okay, so that worked. That's good. So I can use the default for that, for the nest. And then we have a resolve function. So let's add that. Oops, not in the tests down here. Pub fun resolve. Self. Expr. Depth usize. And all we're going to do is self locals borrow mut insert expr depth. And that fails. Trait default is not implemented. All right, nest. Let's just do it. I probably needed to just, all I needed to do was put default in there, and then locals is hash map. No, ref cell new hash map. New. Bar mute needs parens, and insert doesn't work. Oh. Oh. Oh, do we need to make these ref cells? To make them all references? Because that's really what we're doing it on. Right? We're just trying to get the reference. We have the reference to an expr and a reference to an integer, and that's what we're shoving in the hash map. I didn't think this would be the stream today. I thought we were just going to do all this. Okay. I mean, we could do the rest of the resolver code and then come back to this, but I don't know how much we'd have to rewrite, because these are references in Java, and in our resolver they are not references. They're just, well, I mean they are, but they're not that kind of reference. They're not a reference counted reference, which is what Java has by default. Do these all need to be RCs? How would that look here? And when we create them, I mean, we could just do RC new on each one of these, but that would create a new one every time we did a visit. And I don't think we want to do that. We want to have, when we call accept on something, here's accept on an expr. Now if we look here in interpreter, we can say expr.accept. We don't have a reference counted thing yet. And maybe that's what we need. So all of these things need to be reference count. Which means in our parser, that's what the parser needs to generate, is all reference counted wrapped stuff. Right, instead of saying OK statement return statement, we say it's new. So we just create just like in Java then, right? We're creating a reference counted thing. And so every single one of these things would have to be reference counted. And then in our interpreter, when we call evaluate, we're calling evaluate on a reference counted value. Right? Oh. And then this would get RC. But then when we call accept, we don't have the actual RC. We'd have to pass it in. as a reference counted value. Right? That way we have a single throat to choke for this thing. I think that's the only way we can get that. It's just basically re-implementing Java in Rust. So there's got to be a better Rusty way to do this, which I don't know. Is that what we need to do? When we call evaluate, we're returning an object, not an expr. Where do we? So yeah, this gets the value. If this value is it's an expr, but right now it's an option expr. So it would have to be an option RC expr that we would extract here and pass down to evaluate, which would also get an option RC expr. Ooh. How much is this going to break then? Okay, let's go into here. And all these boxes now become RCs. I guess statements don't matter. It's just the exprs that we care about. Epic Blarg says RC all the things. Yeah, that's what we're doing. Yeah, so I think just the exprs need to be, because we don't scope statements. We only scope exprs. So let's see how this goes. And of course, this is going to break all of the parsing. So let's see where we have to. So all the box news have to become RC news. Oops. Right, that's that one. Right. Okay. Let's just comment that out for now. We don't need to fix that yet. Oh, this is for a statement. Yeah, we don't need to RC the statement, but everything else, yeah, this is RC new. Oh, what am I doing? I should be checking it like this before I do anything. RC. Expected R. Oh, okay. So right has to be RC. This is RC. This is RC. Okay. And then I messed up. Oh, great. Where the heck that could be? 173. Oh, I messed this OK statement up. Yeah, when I cleaned it up. Okay. Okay, so that wasn't too painful. Yeah, I don't care about that. I don't care about that. Locals is never read. Okay. Let's just put it like this then. just put these like this so the errors go away. That way, if we introduce warnings, we can... right, and we're still not calling resolve. I don't know where you call the resolver. Okay. Okay. There. All right, so now do we have, oh, after all that, do we have RCs for all these guys? To reference count them. What did I just do? I modified all of our experts now are reference counted here. Oh, right, these need to be reference counted as well. Those are statements. There's a RC expert, option RC expert, and that way we can okay. Am I even doing the right thing? I don't even know if I'm doing the right thing here. Because if I make all these changes now, oh wait, cond is, what is it complaining about cond? I was automatically wrapping it in an RC, but I don't know. Expected struct RC found expert. Right, okay. RC new. Condition is up here. We can just say RC new. Then branch gets an RC. Oh no, it doesn't. This is RC new. Value gets RC new none or RC new sum. Oh, I think it's in the inside. Yep, and then initializer is going to be same thing. RC new. And condition here. Expert. Okay. Let me check to see if this tests. Oops. Oh yeah, because I broke all the tests. What locks code do we have here we can run? Cat cargo run block dot locks. Oops. It still works. That still works. And we have the fib, cargo run fib 21. Yeah, that's still, and that breaks. And then we have the recursive fib. Yeah, okay. All right, so we haven't broken it yet. But we haven't gotten very far, right? Because now we have all of the... All of these things are reference counted. So when we use them, after all that, I think we want these to be all RC'd, right? But our self doesn't have. All right. So we might have to say self and then RC of self, like this. Which is this just going to be the self value, and now that's what we pass in here. All right, let's try that. And then generate. So in here, we say wrapper RC of self. That's a base name 2 lowercase. I think for the first one we just want base name, right? Yeah, and now resolve statement has to pass in the wrapper. Okay, let's comment out the resolver again, because the interpreter is the thing that's going to be the pain to fix. So wherever we call evaluate now, we have to pass in a wrapper. Right? Like that. Nope. Expected struct RC found statement. Oh yeah, because this is RC. Nope, doesn't like that. Oh! This is a statement. We don't... Well, we still need to do RC statement because I changed it generically, but we don't need to pass in... What does visit return statement look like? I've already forgotten. Oh, right. I didn't add the wrapper to any of these guys. That's why. Yeah. So all of these, I have RC expert here, but I forgot to add it to these guys. Okay. That's easy to fix. Wrapper RC of base name. Right, and now, oh, I put it in the wrong spot. Oops. Not that there. We do need to pass in the wrapper though, here. But where we create it, down here, fn visit oh, this needs to be RC'd. Got it. Okay, so now if I look at Expert, we have the wrapper, we pass the wrapper in as an RC, and then we have it here. Okay, so that's good. So that's working. So now we have RC statement that says expected RC, right? And we'll have to do that everywhere. So, RC statement, RC statement. And this is RC expert. I wonder if I'm not supposed to have an ampersand in front of that. And now this doesn't like it. Supplied 3 arguments, but was expecting 2? Yeah. Oh, there's 3 right there. Oh no, wrapper and an expert. Oh, so maybe we don't need to pass in self anymore. Yeah, mod. Oops, it was right there. There it is. Okay, so now self-evaluate. We do need the expert that we're evaluating, which is where? We don't have that. Oh, we don't even have that now. It is statement value. Statement value should be the RC. No, value now. So that worked. So we don't actually need this. Oops. That was my password manager updating things and then making the screen go funny. Okay. So we can do it this way, right? We don't need to pass in that. Oh, and this becomes wrapper, expert. Okay, so now evaluate arguments. Oh, I should have kept that. Expected RC found in an expert. So the argument is, it's no longer a... Manda, thank you for the follow. Yeah, I'm struggling on this one, aren't I? So now evaluate is no longer taking an expert, it's taking a... I can't, if I say RC new just to get around it, that's going to be painful. What did it find? Oh, it found an expert. Oh. So that means these expert arguments. What are the expert arguments in our call expert? They're a vec of experts, and they need to be vec of RC of experts. Okay. Wait, where? Oh, there it is, up there. Okay. So now that's going to blow this. No. Where's our parser? Our parser has to be fixed somewhere. Yeah. Arguments push. For each one of these has to be on RC. Like that. Okay, so we don't need to do this anymore because we should be passing the RC. This is expecting an RC found interpreter. Uh-oh. Oh, this is for evaluate. Yeah, that's what we're working on, evaluate. Okay, hang on. Source expert. Accept takes a wrapper and an expr visitor. Oh, I have it backwards. That's why expr self. Right, and then this should be statement itself. And this needs to be RC'd because you change one thing, you change everything? No. Maybe? Oh, okay. Yeah, so those are boxed instead of statements. Okay. I guess we do expr and we do RC all the things just like Epic said. Get rid of all the boxes and turn them into RCs. And then we have to fix our if and our while in the parser. It's saying I found a statement even though... Oh.
What is this place?
Like that. There we go. Expected slice found struct RC. Oh, did I RC the wrong way? Body. This should be a vec, right?
What is this place?
Oh no, it was box of a statement. I thought the body of a while loop would be... Oh, maybe it's a single statement that's a block statement. That makes sense. So then what's the error? Well, this is in locks function, which we haven't looked at in a while.
What is this place?
Why don't I change this to, instead of RC statement, we'll just say vec of what are we passing in? We expected this and we found this. Yeah, so RC of... Can I do it this way? No. And then, so now in our block statement, it has to be a vec of RC's statements, right? Or RC of vec of statements. Mod. Like that? Almost. Expected reference found statement. So now this statement here comes from here. And we're iterating all over each of the statements. And statements is definitely RC of vec of statements, and we're expecting RC of statement. Do I have to say RC of vec of RC of statements? And execute block has to be modified to handle that. Wow, this is the worst. And now we have this problem here. Oh, that body is vec of RC. And now we have declaration body. So that means function statement needs to be fixed. Yep. And now we have to execute this. Oh, this is interpreting the statements that come back from okay, so then here, this is going to be this. Okay, and then expected struct RC so we're going to have to put RC new everywhere, I think. Expected struct vec RC statement found struct vec statement. Oh, that means the block has to return a vec of RC statements. Sorry, so that's where we're going to have to put RCs everywhere. Oh. Vec of RC statement. RC new. And I messed this up somehow already. There we go. That's expression. That's the expression statement. There's the RC new. And then we need the vec and then, okay. Nope. I'm trying to wrap the whole. Oh, this needs to go here. Okay. And then that goes there. That's the block statement, and that's the block. Still no. We have the new vec. Contains a body followed by this guy. Right? Let's get rid of that. Oh, this is not right. Okay, so this is for the expression statement. This is for the expression. This is for the vector. That's for the new. That's for block statement, and that's for the block. Close. Okay, so the body needs to be RC new, like that. RC new, like that. And this has to be RC. Wow, okay, this is really painful. I think I chose the most painful way to do this. Oh, it's already at RC. Well, it would be if I did this. And then it returns a body, which is the RC statement. Oh no, that means everywhere has to be an RC state. Oh my god, what did I do? Okay, I went about this all the wrong way. I'm gonna have to abort this whole process and then think of a different way, different approach to this, because this is not working. if I have to RC everything, yeah, so that gets that. Var declaration needs that same type, otherwise it's not going to work. So yeah, everything needs to be RC'd, which is going to be... Okay, this is the wrong approach. This is clearly the wrong approach. Function... I don't know why I'm still going. I'm hoping eventually it'll stop hurting. And an if statement. I guess what we could do is this. Why can't I do that? Expected enum result. Oh, okay. Yeah. That way I don't have to change each one of the things. Okay, RC new. Oops. RC new. Okay, RC new. Yep. So that failed also. All right. I'm going to, because I'm not getting anywhere with this, and I'm going to have to restart from scratch. This is just a gigantic mess just to get the the references, because what we need to do, right, is all we need to do is store a reference to the expression and say what its depth is. For each expression, we need to do that. So what have we done so far? We did the scanning, right? I'm just thinking about the process of interpreting this stuff. So we have this here. We scan the source using scan tokens. Tokens then becomes this list of tokens, the vector. We then parse it using the parser parse, and that returns a list of statements. Now the statements are abstract syntax tree, right? We have, for each statement is a little mini tree that has all of our other statements and expers within it. And if we look at exper, we have all these different types of expers, and each one of them has its own type, right? Which is this exper enum with a destructured version of it that contains all the data in it. And it's these little guys here that need to be put in here to say what scope they are. But I don't know what other way to handle this if and else have incompatible types. Oh, that's why I need to do it the other way. Yeah. That's why I can't do it the way I was just doing it now, because the var declaration has one way an expression statement. All right, let's try it. RC statement. Oh. Yeah, it should be a, it should be a vec of, I don't know why I'm still doing this. I'm hoping eventually it'll just work. Where were we? We were in the for statement, which doesn't exist, right? Because it's a while. And we're creating a block statement, and the block statement has RC vec of RC statements. Oh, expected struct this, found struct this. Oh, is that because my statement thing is broken? Then branch for the if. Oh yeah, it takes an RC statement. Okay. And the else branch as well. Oops. If has an RC statement for the then branch and it's saying it's expected. Oh. I guess it's already returning that type. And then body needs to be RC. No, it needs to be expected enum. Oh. Okay. I mean, this might be the only approach to this. And we're doing the double RC thing again. Okay. And the warnings are because we're not using wrapper and we're not calling resolve. Okay. It actually compiles. I have no idea. Let's try fib21 recursive. Oh, nope. Cargo run that. Cargo run recursive fib. Okay. Cargo run block. All right. Well, I guess we managed to massage it into shape. Get status. Git add generate and source. Git commit RC all. Let's do it in single quotes. RC all the things. Just like Epic said. Oh, and I forgot the single quote there. Okay. All right, so now, does this give us enough to play with the resolver? Oh, we're going to have to comment this back in. Right, and now all of these need to change. RC statement. Oh, that has to be expert. Okay, and now we have issues where, right, we're expecting different things here. So this needs to be, I guess, wrapped or unwrapped. So resolve is now expecting an RC of vec. Come on, back. There we go. Of this. Okay. Oh. Okay. Fixed. And now statements doesn't work. It's not an iterator because it's an RC. Can I do that? No. So how do I iterate over the vector that's inside there? Can I use our magical deref? Apparently I can. Okay, and then in interpreter, how do we do the accept? Statement.accept. We say statement itself. And this is expert itself. And these are RCs. And now we're down to 2 warnings. Oh, an interpreter. Source interpreter 24. Guess we don't need that. Okay. And after all that, I don't know if this is all going to work. Right? Where did we leave off? I don't even know. I don't remember where we left off. Let's pull up our resolver. We did visit var statement. Oh, right. And then we did resolve local. We had just written resolve local. Okay. And then inside our interpreter, we have resolve, which is not. Oh, right. We have to see if this works now. Our hash map should be not expers, but RC expers. And of course it doesn't work. Oh, depth. Expected reference. Found reference. Oh, this needs to be an RC. Right, and a resolved local then needs to pass in the wrapper, and it does. Okay. Right, and then locals has to. Oops, there it is. Has to be fixed, and then we can't insert. Method can't be called on a ref mute because. Oh, because this doesn't implement hash. And that doesn't implement equal. And I don't think I can implement those, right? I thought references could. Oh, maybe expert has to implement equal and hash. Let's try it. First, we'll change our build so we don't have to mess around with that each time. Oops. Just say okay. Right. And this will let us modify expert without it being overwritten. So can we do this? Can we say impl hash for expert? And then what does that need? Oh, I have to import hash. Standard hash or core hash. Use standard hash. And so how do you implement this? I have to implement function hash, okay? To do. Okay, let's figure out how to do it. If we have, oh, can I do it? Can I do this? I guess is the big question, right? And this is going to need a name. Implementing Asher for C type. I think this is what I need. Nope, it is not. So I'll have to say Rust. Oh, do I have to do that? Create a separate struct for it, and then change all of the, and then go through all these and change all these. Oh, say it ain't so. Can you just do it directly, or do you have to go through that separate type? Yeah, this also has a separate type. Oh boy, so I just did the wrongest thing in the wrongest possible way. Yeah, oh boy. Okay. Yep, I'm calling it a stream. We're done here until I can think of a better way to handle this. Okay, let me push up what I have so far. And then we'll fix things up later. Oh boy. Okay, so thanks everyone for hanging out. I'm sorry we didn't get very far today with this whole resolving thing. It felt like we were getting close with the reference counting, but it turns out we need to actually reference count. We need to be able to hash the reference counter itself, and we can't do that yet. So I'm going to go off and I'll learn how to do that, and then tomorrow, Friday, maybe we can get section or chapter 11 done. Because once we figure out all this, I think the rest of it's going to be straightforward. It looks like the code itself is pretty simple. Epic Blog agrees that this sucks. Yeah, thank you. I appreciate the emotional support at least. That's good. And then interpreting is the resolve. And then we have to look up variable. Like I said, if we can just figure this out, I think the rest of it just fall into place, and maybe tomorrow we'll be able to do that. So let me do that tomorrow because I'm not getting anywhere today. All right, everyone. Thanks for hanging out with me. Sorry it didn't end in a better way, and I will hopefully see you tomorrow. Take care.